Today's lesson is over section 4.8, where we're talking about antiderivatives. Now to start, let's work on a warm-up. So here, take these following examples and find the derivatives. Please stop to give yourself a chance. Right, now that you have given yourself a shot, let's see what those answers are. So for letter A, it would be 4x cubed minus 2. Letter B, remember that cosine squared can be written as cosine to the second power. So here you got a little chain rule. So 2 cosine, derivative cosine is negative sine. So together it's negative 2 cosine of x sine of x. And that's your derivative. So an antiderivative is a function where f is on an interval I if capital F prime of x is the same thing as f of x. So that means that we kind of introduce that the function is actually the same thing as a derivative of something else. So we kind of work our way back. So an example of this would be f of x equals x squared. And so the antiderivative of that would be x cubed divided by 3. So if we took the derivative of x cubed divided by 3, you would bring that 3 down, and then the 3 divided by 3 would cancel out, leaving you with x squared. Now, one of the theorems we talk about with antiderivatives is that on that interval I, there's going to be a most general antiderivative because there are other things that we might have canceled out or constants that might have gone away. So we have to include a c value at the very end of any antiderivative that we take to give us an opportunity to either state what it could be or allow us to find what they should be. So here, for this slide, please take a moment to pause the video and then copy all these down, because these are common antiderivatives that we will see. So for example 1, we have the derivative of f prime of x, which equals negative 4 cosine of x plus 7 x to the 4th minus 2 times the 5th root of x squared. So before I take any antiderivatives, rewriting the radical into an exponential function will allow me to take the antiderivative a little easier. So here, using that table, the antiderivative of cosine would be sine, so I'm replacing that. Now, because x to the 4th is a power rule, and so I use the exponent, so x to the n plus 1 divided by n plus 1 kind of notation. So notice that 4 plus 1 would be 5. And then it's the same thing. My n plus 1 would be 4 plus 1, which would get me 5 in the denominator. I do the same thing for the radical piece. So plus 1 would be 5/5 for x to the 2/5. So that's how I'm getting the 7/5. So when you have those, the denominators will be the same, which is very convenient. You don't have to worry about that. And then from there, I want to simplify as best as I can. Now, when I have a fraction in the denominator, I'm going to have to multiply by the reciprocal, so that's how I go from 7/5 to 5/7. And then I can multiply across. Now, with the negative 4 sine of x, there's nothing else to simplify. Same with the 7x to the 5th divided by 5. Nothing to reduce there. But now I'm able to get minus 10x to the 7/5 divided by 7 plus the c value. And since there's no value to help me find what c is, I'm just going to leave it in that form. Now, letter B, this one has a extra piece of information saying that at x equals 1, we know that y is equal to 2. And so once we've taken the derivative, this will allow us to find what c is for this example. But first I need to find my antiderivative. Now, remember, e to the x derivative of itself is itself. So for 5e to the x going backwards would be the same. So that's why I keep it that way. Now, x to the negative 1 is to the 1/2 power, so it follows the power rule. I don't have to worry about any chain rule or anything here because the derivative of x minus 1 by itself on the inside would be 1. So we can kind of ignore it for right now. There will be other problems down the road that we'll deal with, examples that have chain rule in them. Okay, so then that 3/2 gets multiplied by the reciprocal to the top, and I get negative 4/3 instead. And so then now I can plug in what I know. So I'm saying that x is 1, so I have to plug that in everywhere I see an x. And this will help me find what what my c value is. Now notice 1 minus 1 on the inside there is 0. So that whole expression, or that term, is going to be 0. So I can kind of just get rid of it. And so then I'm left with 2 equals 5 times e to the first plus c. And I want to solve for c, so I move the negative 5, or the 5e to the first to the other side. And that allows me to get c is equal to 2 minus 5e to the first. Now sometimes you get expressions that you could probably put them into a calculator, get a decimal, but we want the most exact. So we're going to leave it in that form. So when I put this in, I get 5e to the x minus 4 times x minus 1 to the 3/2 power divided by 3 plus 2 minus 5e to the first. And that'll be my answer. Okay? Let's do some more examples. If you'd like to stop the video and give these a whirl first, go ahead. But I'm going to keep on going. So here, the derivative, or the antiderivative of 5e to the x, be 5e to the x. X to the 5th is a power rule, so it'd be negative 2 times x to the 6th divided by 6. And then secant x tangent x is the derivative of secant of x, so I pull that out, plus c. I can reduce the 2/6 on that one, so and that's about all I can do, so that will be my answer. Okay, now letter B gives you 2 derivatives, or the second derivative, so we need to go back twice, which sometimes they give us. That's why they kind of gave us 2 values, because here I'm going to actually have 2 different unknowns, c and d in this case. So I do all my antiderivatives twice, and I get, now notice that c catches up because it's a constant, it gets an x there. So it's going to have another thing attached to it. So if I had a third derivative, I would have cx squared divided by 2 and a dx and an e. So I put in that first point of j of 0 is equal to negative 1. It helps me find what d is, which is negative 1. Then plugging that in, now I can use the second point to help me find what c is, to get my value to be 2. And so now I'm able to find that my original function is x to the 5th minus 2x cubed plus 2x minus 1. Okay, have fun.